Hi students, welcome to virtual class of Municipal Corporation of Greater Mumbai. I am Sreekumar. The class is for 8th standard students. Subject is mathematics. Let me begin the class.
Dear students, you studied about rational numbers and representing national numbers on number line, but there are certain rational numbers and numbers on number line which are not that easy to represent. Among those, the numbers are root 2, root 3, root 5, root 7, etc. are difficult to present on a number line. We cannot straight away present it because their answers root 2 is 1.414 non-recurring and non-terminating. Where exactly on number line it would be. We know where is root 4. Why? Because root 4 is equal to 2. So 2 is root 4. So there is a technique by which we can represent these numbers on number line. That is what I am going to show here. Mainly of doing, less of talking it is. So you should keenly observe how I am doing it. Pause the video, reverse and go back and come back again, rewind the video so that you will get it clear. I will also take utmost care to do it perfectly, but digital board is having its own limitation. Even then, I am trying to do it for you. We need at least compass and scale for any such construction. So I'm taking it out first. Then I'm taking a little bigger unit here so that you can see it perfectly. And these are not in centimeter or meter, this is just unit, and the concept is also like unit concept. I will make you understand. I'm trying to draw a number line and I have to mark the minimum required unit on that. Let 0 be here, 1 here, 2 here and 3 here, minus 1 here, minus 2 here and minus 3 here. Okay, you understood what I am doing. Now we have to draw root 2. We are applying our common sense and Pythagoras theorem to do that. You will come to know the idea used only after making it happen. So let me do it. First I am going to draw a perpendicular at unit 1. This distance let us consider as 1 unit. That means up to here it is 2 unit and up to here it is 3 unit. So I have to draw a perpendicular at unit 1 now. Bringing the compass here, I need to make an arc over here. You have studied about it. Another arc over here. I would like to make this line little thinner for better appearance. Okay. Now I have to increase the expansion of the compass and do the necessary for drawing the perpendicular at 1. You have studied about the technique of drawing perpendicular from a point on the line. That technique is used here. Bring the scale over here and draw the perpendicular. After drawing the perpendicular, what I am going to do is the important thing here. Measuring this unit, 1 unit, exactly on compass and taking the equivalent on this perpendicular which I have drawn now. This distance is also 1 unit, right? Now comes the importance of Pythagoras theorem. Pythagoras theorem, which tells, or we have understood and applied, that in a right angled triangle, hypotenuse square is equal to sum of the square of other two sides. This is other two sides. That theorem, if we apply over here, here is a right angled triangle. If we construct, like from 0 to here, if I draw, this becomes a right angle, right? In that right angle, one side is 1 unit, the other side is again 1 unit. In that case, I apply that in the theorem here, where hypotenuse square will be equal to 1 square plus 1 square, which is equal to 1 plus 1. In which case, let me mark this as P and Q. Then I can say in triangle OPQ shown here. That means this is equal to 2. So hypotenuse square is equal to 2 means naturally hypotenuse will be equal to, here in this case hypotenuse is OQ. OQ will be equal to root of 2. That is what we want. That distance root 2 we want. We got it. So let me make this very clear to you. This became root 2. So I will do one thing. I will remove this rough one from here, and I will make this line perfectly correct, because we understood that hypotenuse square, hypotenuse over here, this length is equal to root 2. Let me draw the length root 2 over here. It should be drawn from 0, please remember. As I told you, digital scale management is a tough job, in fact. Okay, bear with me, it's my limitation. I am drawing that. You understood what I did. This is equal to root 2 now. If this is equal to root 2, the length, root 2 unit. If it is centimeter, root 2 centimeter. Why can't I trace that to the number line? Then I can mark it. This length is root 2 according to the principle now. So I am bringing that down. This point I will mark as root 2 without any hesitation. Root 2 is drawn or shown on the number line. Next comes root 3. How to draw it? The technique is again applying the same type of common sense in such a way that I am drawing a perpendicular at root 2 now. For that, I should draw arc on both sides. Expansion increased. Keep here. Again convenient height. Sorry. Take a convenient expansion, I would say, so that it won't disturb anything else. We are going to draw at root 2 a perpendicular this time. Accordingly, we will mark the arc. Oh, then I have to keep it back again to complete it perfectly. This way we can draw a perpendicular at root 2 now. This way we can draw a perpendicular at root 2 now. You have to bear with me, as I told you, there is some jerk always for this scale. Okay, this is root 2, a perpendicular at root 2. Again, I would like to tell you that this distance is equal to root 2, we know. Going to take a measurement of a unit distance again on this perpendicular. From 0 to 1 is, we know, unit distance. Take that measure once again and draw that on this perpendicular now, like before. This is 1 unit again, like before. Now what happens if I draw a triangle here? Here it is 90 degree, right? So the same way it will work out. What will be the value of it? We will see. In the new triangle, there where it is right angle here, hypotenuse square is equal to, one side is root 2 whole square, the other side is 1 unit as we have done. This means root 2 square is equal to 2, 1 square is 1, which is equal to 3. That means hypotenuse is, this case, is equal to root 3, which we require. So our problem solved here again. Once again we are getting the distance or displacement of root 3 perfectly. Take the scale there and make the complete the right angle triangle of which hypotenuse is equal to root 3. This is root 3 distance, and our compass will take the measure like before. Take the distance root 3 and mark it onto the number line. That means here it is root 3, this point. Again, root 3, 2, we know 1.4141, like that it goes. Here it is 1.73202, and this is root 4, we know. This is root 2, root 3, root 4. Next target is making root 5. Again we will draw a perpendicular at root 3 now, this time. At root 3 we have to draw a perpendicular. How to draw a perpendicular you know now, so I am not wasting time on taking the compass and drawing. Instead I am drawing the perpendicular approximately using the scale, not because, just because to save the time of the video. So another perpendicular is drawn. I will change the color for you to see it clearly. Let the perpendicular drawn this time be of different color. This I am doing with the scale because now already 2 perpendiculars we have drawn, and you should follow the same principle and method in this case also. So you are having the third perpendicular, which is at root 3. Now why I did it this way? Because our common sense and application should be on another aspect now. Now to draw root 5, what to do? We need to apply our common sense and the Pythagoras Theorem. We need to get hypotenuse equal to root 5, correct? So the technique is that if you take one side of the triangle as 2 and the other as 1, this will become 2 square plus 1 square, which will be equal to 5. So how to get one side as 2, which is quite easy for us because 2 is already there on the number line. 1 unit is also there on the number line. So drawing root 5 has become easy comparatively, correct? So let me go for that. First I have to draw a perpendicular at 2. Drawing perpendicular, I have already shown you 2 times in the case of a perpendicular at 1 and a perpendicular at root 2 is already drawn. So here I am, instead of doing it in that using the compass and all, I am going to straight away draw a perpendicular in order to save the time of the video, I would say. So please cooperate with me. Let me take the scale for that purpose, and I am drawing a perpendicular straight way, otherwise even set square also can be used. With the help of scale I am drawing the perpendicular. Okay. A perpendicular I am drawing at 2 straight way, but you will be doing it with compass the way we did at root 2 and root 3. Okay. Now perpendicular is drawn at 2. This part is done. One side is 2. The distance from 0 to 2 is known to you. And we will have a measure of 1 unit on that, just like before. For that I need compass. Take the compass and measure 1 unit from here, like before. Mark that 1 unit on the newly drawn perpendicular simply. Now we know, according to this Pythagoras theorem, hypotenuse square is equal to one side square plus other side square, where it is 2 square and 1 square. Again, this is 1 unit like before. If you make a triangle here, considering this as a right angle, the hypotenuse will be having root 5 as its length. Root 5 unit. So let me draw the hypotenuse of the newly formed right angle triangle. Okay, that means we are here representing root 2, root 3, root 5, and one more is the root 7 on number line. You should practice this with interest in your notebook. So this length is equal to root 5. I'm writing it over here. Bring the compass. If compass expansion allows me to draw that big, I will measure it and show you. Yes, this length is root 5. So why can't you take that measure on to the number line, which is our purpose? So here it touches. That means this is root 5. Understood? Okay, so we could do root 5 also. So now you could find that drawing root 5 is quite simple because it starts with 2, which is already marked on the number line. Now you are asked to draw root 7, which is the last one in this question. For that you should go for a drawing root 6, then to root 7. To get root 6, we have to draw a perpendicular at root 5. So how to draw a perpendicular is known to you, and last time I did with the scale. This time I am going to draw the perpendicular with the help of set square in your compass box, which we seldom use. This is the set square. Normally we don't get opportunity to use this, so I thought I will use it for you now. Keep it here where we have to draw the perpendicular rotate it in such a way that it coincides with the line on which we have to draw the perpendicular. See. Set square is a instrument having a 90-degree angle, a right-angled triangle it is. So we got one side coinciding with the number line, the other side we will be drawing the perpendicular now. Okay. The perpendicular is drawn. And on that perpendicular we will be marking 1 unit just like before. For that again we need the compass. Take the compass and measure 1 unit once again from 0 to 1 like always. Bring it here, turn the compass and mark 1 unit. Now we know that this is one side is root 5, hypotenuse square is equal to root 5 square plus 1 square. This we have taken 1 unit like before. Root 5 square is equal to 5 plus 1 is the answer here. Hypotenuse square is equal to 6. That means hypotenuse is equal to root 6. We cannot jump to root 7, that's why I took this step. Okay, so let me do that. For that, I will be completing the right-angled triangle here to show you the hypotenuse which is having the measure equal to root 6. This length is root 6. If this length is root 6, compass is used to get the exact expansion of it and bring it onto the number line to mark root 6. I marked root 6 over here. Where I have to draw again a perpendicular in order to draw root 7, which is the last stage. Again, I will be bringing the set square to do that quickly and accurately. Bring the set square to the point where you have to draw the perpendicular. Draw the perpendicular. The perpendicular is drawn. This is the perpendicular. Again 1 unit distance on that perpendicular like before. Now we understood the technique and the application of Pythagoras theorem to draw this. So we don't have to say that again, only we have to speed up our drawing. Okay. Mark that point of 1 unit. Remove the compass. Take this scale over there. What is happening here is hypotenuse square is equal to root 6 square plus 1 square, which is equal to 6 plus 1, which is equal to 7. Then hypotenuse is equal to root 7. Same principle. So we will be simply connecting this point to that intersection of arc on the perpendicular, and you get the distance of root 7 over here. Then bring the compass like before. take this expansion exactly. This is equal to root 7 and complete that onto the number line and you mark it there. So you could mark root 2, root 3, root 5, root 7 on number line. Okay. I took nearly 20 minutes to do this. More than that. You also will be taking that much time at the beginning. You will be doing it with pencil. There won't be this kind of color display by you. But you will do it. It comes again in 9th standard. You will practice it in such a way that you know to represent not only 1, 2, 3 on number line, not only 3 upon 2, 4 upon 8 or any such rational numbers. You also know now how to represent root 3, root 2, root 5, root 7 and many such numbers on number line. Number line is having a very point defined in this way. If you learn mathematics more, there is something, a very serious concept of number system lying under this. But for the time being, it is about representing number on number line. Be thorough with it. The rest will follow naturally. Thank you.
Now click on the subscription button below to subscribe the channel, then the bell button to get the notifications of the new videos. Thank you.